Hi, I'm Murat Sever. I'm currently a PhD student and a part-time lecturer at Tobetti University, located in Ankara, Turkey. At our university, we made a transition from hardware-based communication system laboratory work to STR, and we have extensively using GNU Radio. Today, I'm going to share our experience with you. So, I'm going to talk a little bit about the motivation for starting such a change, and then give you information about the curriculum that we have prepared. We have developed an undergraduate level laboratory coursework to teach communication systems to undergraduate students. So we also prototype a standalone kit that we can use in education for educational purpose, and developed a graphical user interface, a simple one. And lastly, I'm going to conclude with our future plans. So what are the problems in teaching communication systems? They are complex in nature, and they include many subsystems, and they involve theory that's theoretical and hard to understand. Most of the time, laboratory work consists of simulations or some experimentation with hardware-based solutions, which are both expensive and difficult to set up. So the solution we are looking for should have an open architecture. It should be modular and extensible, should include real-world signals like narrowband or wideband FM or ADSP signals, or a signal from a remote key, and should be software-based, supporting professional development of students as well, and it also should provide us remote work opportunity. So simply, we ended up with a simple solution, a low-cost STR, which is RTL STR, that has only receive capable, and everything is installed on student's laptop. And we also developed a curriculum. All modular things are based on Jupyter notebooks. It has many modules, and we begin with a DSP module because there are students new to the DSP world, and STR module gives introduction to RTL STR, and Python or MATLAB module gives programming with Jupyter notebooks and other libraries, and all other communication system modules consist of we use Python, or they have records and walkthrough examples, and students take records and validate their algorithms to run on their own recorded signals. Students also apply their algorithms to the records themselves. In classes, I also transmit if there is no chance of low opportunity to be found over the air signal. So students catch it and record it and use the signal as a signal source. And we use GNU Radio for both signal analysis in real time and offline. And I'd also like to mention that I use GitHub Classroom application. It's a free application for academic use. So it's easy to manage assignments with it. So, and we can automatically grade the assignments. It also allows you to watch the progress of the students and give necessary comments to them, or collaborate. It provides a collaborative environment. So our main aim is to engage students more into communication systems through real-world signals. We also help them on their professional development, and like building and improving their programming skills. The course is unique in some points. It has a mixed content like GNU Radio, general purpose applications and programming. And programming language can be Python or MATLAB. They are both supported, and it's remote ready. And this is a 10-week program in total. And in the first half, we go over installation of tools on students' laptop, introducing them to environments, to like Markdown language, Markdown, GitHub, and JupyterLab. We also go into the USB with GNU Radio, prepare them to our real topic. In the second half, we go over analog modulation examples, both from IQ records and over-the-air signals. We also see examples of digital communications. We have digital communication example, end-to-end example with QPSK and ADSB signals. I taught the newly modified SR-based course, laboratory course, 2 times so far. I received good feedback, and according to surveys, the students tell they grow interest in communication systems and they learn tools that are helpful in their future career. And this is the most standing out part maybe. I asked the students about their favorite module, and according to the polls, 2 GNU Radio modules became the most liked ones. At the first, I was surprised, but when I got the result for the second time, I taught at fall 22, and the same result again. So GNU Radio is the winner. We will see that what will be the result for fall 23 in a short time. And we were also investigating a low-cost embedded standalone system that we can use in other projects other than telecommunication projects. So like projects like computer vision, robotics, or other AI applications. And we decided to design the kit with NVIDIA Jetson Nano single board computer because it gives us heterogeneous compute platform to run a broad range of applications. The prototype also includes a touchscreen display and a sound card, and it's a prototype, but it can become a portable one. We are utilizing Nano STR distribution from STR Technologies for Jetson Nano. It includes most of the popular software, so the student this time is eliminated from the installation process, and it can be used directly, instantly. So we later developed a simple GUI that easily launches the installed software with just one click, make it easier to use for ones with little experience, with little knowledge on devices or applications. The left image shows the main window, and when you click one of the buttons, then GQRX or ADSB application, general purpose applications are shown, launched, and this way the user can easily watch common signals like narrowband FM or ISM band or ADSB signals with just one click, and they can start IQ record too. And we have 2 big supporters, and I would like to thank them. NVIDIA has granted us Jetson Nanos through their academic hardware grant program, and we are also one of the grantees of ARDC. They support us to develop SDR-based education materials to help us improve our course content through their education support program. And this project is a work in progress. We will add more modules covering advanced concepts and maybe graduate study, materials for graduate study. And we also would like to use GPUs for accelerated computing and maybe add deep learning applications as to introduce students to this field. And thank you very much. I would like to also thank Dr. Michael Lustig from Berkeley and John Pauly from Stanford, and Dr. Mark Leishman for their help providing us the course design, and I used their course materials and to design the course structure. So thank you for your attention. I really enjoyed my very first GR conference here. I'm happy to be here and hope to see you again. Thank you.
Thank you very much. Do we have any questions? We have some time.
So this morning there was a talk expressing interest in integrating GNU Radio and Jupyter Notebook. You mentioned that in your slides. Have you been doing that? Have you worked on that?
Yeah, actually, Jupyter Notebooks for GNU Radio integration, actually, they are separate. Most of the time, we are using Jupyter Notebook for programming MATLAB or Python coding. Yeah.
Do we have any more questions? I have one question. So, when is the first time you did this class?
It was in summer 21, I think.
21, okay. So you mentioned like some testimonials from your students. They were very happy. Have you had students go, like go for work after and then like say, okay, I really took some skills from this class that immediately helped me, I don't know, in my industry job or something like that?
Yeah, students mostly from third grade, and they can find internship easily, and they found the class helpful for their internship, and when they work in telecom job, which is not very much in Turkey actually. Yeah, the course helped them. Yeah.
Okay, very, very cool. This reminds me, last year we had a keynote, I think it was last year, by Dr. Laneman from Notre Dame, who talked about various software stacks and their various, curricula. And this is just a reminder that you can watch all of these talks later online. That particular keynote was an excellent keynote, and it talked about these things. Well, thank you very much. This was very interesting.